All right, welcome to the deep dive. Today we're going to be zeroing in on, well, you might not think about it every day, but it's super important for tons of modern tech.
I'm intrigued.
Yeah, so we're talking alumina substrates.
Alumina substrates. Okay.
They're like the backbone material for, I don't know how many electronic devices and industrial applications.
Right, right. I mean, it's one of those things that's sort of hiding in plain sight.
Exactly.
It's everywhere, but we don't necessarily think about it.
Yeah, it's everywhere. And they're made of aluminum oxide, AlUs,
Yeah.
for those who remember their high school chemistry.
Yeah, for the chem nerds out there.
These components are really amazing. They've got exceptional thermal conductivity, impressive mechanical strength,
Wow.
top-notch electrical insulation.
So they can handle the heat, they're tough, and they don't leak electricity. What's not to love?
Exactly. Think of them as the silent workhorses in everything.
Okay.
From your car's computer systems to massive energy grids.
Okay.
I mean, they're everywhere.
Yeah. So for anyone listening who really wants to get a good understanding of key technologies without having to, read through tons and tons of data.
Right.
Think of this as your express lane. Shortcut to understanding this really crucial piece of the puzzle. We've got this market analysis report.
Right.
Just packed with information, and we're going to pull out the need-to-know stuff.
Exactly. Distill it down.
Exactly.
We're doing it easy.
By the end of this, you'll know where the Alumina Substrates Market is at right now, where it's going, and why it really matters.
Yeah.
Big picture stuff.
Exactly. So let's start with just a sense of the size of this.
Okay, yeah.
In 2024, the global market was about $1,624.5 million US dollars.
Wow, that's a big number.
It's not small, and projections show it hitting $2,589.2 million by 2032.
Okay.
Growing at an average annual rate, that's the CAGR, of 6%.
So steady growth.
Yeah, this is not a tiny little corner of the market.
No, it's got some serious momentum.
Yeah, it's going places.
And one of the big things driving this is the just constantly increasing need for these advanced electronic materials.
Across so many different industries.
Oh, yeah. I mean, everywhere.
Yeah.
Think about cars, right?
Okay, yeah.
They're basically computers on wheels now.
Right.
With driver assistant systems constantly processing information. They need a way to get rid of all that heat.
Right.
And that's where alumina substrates come in.
Okay.
And then you've got consumer electronics, always getting smaller, more powerful, need materials that can handle all that extra power.
Right, right.
Industrial automation, they need electronics that can take a beating.
Right. Robust and reliable.
Yeah.
Here's an example of how this is changing.
Okay, yeah.
Just last September 2023.
Pretty recent.
Yeah, Kyocera Corporation
okay.
unveiled a new alumina substrate, much better thermal management.
So it can handle even more heat.
Yeah, yeah. And this could be a big deal for high-power electronics.
Yeah.
Especially in things like automotive, aerospace, even renewable energy.
Interesting. So a seemingly small tweak to the material can have these huge ripple effects.
Right, right. That's what's interesting about it.
Yeah. I mean, it really highlights how important materials science is to pushing the boundaries of these different fields.
Right.
This better thermal management, I mean, it doesn't just mean more powerful electronics. It could also mean smaller and lighter devices.
Okay.
Longer lifespan.
Right.
And that could change how we interact with technology in some pretty fundamental ways.
All right, so let's dig a little deeper into where things stand right now.
Okay.
We know the market was at $1,624.5 million in 2024.
Yeah.
What are some of the key trends we're seeing?
Well, that number, it just shows how strong and consistent the demand for these ceramic substrates is.
Right.
And a major trend is the growing use of high-performance ceramics, specifically for power electronics.
Okay.
As electronics get more powerful, they generate more heat. And alumina's ability to dissipate that heat becomes even more critical for both performance and just making sure those things last.
Exactly. And we talked about that 6% CAGR, leading to that projected $2,589.2 million by 2032.
Right.
What else is driving that kind of growth?
Well, a few things. The increasing use of next-generation semiconductor devices. They need more sophisticated packaging and better heat dissipation.
Right.
Then there's this global push for energy efficiency and sustainability. And alumina is a very durable material. It fits right in with that trend.
Right.
And, of course, the demand for wireless communication, high-frequency circuits, advanced computing,
Right.
all areas where alumina substrates really excel.
Right. Okay. So let's talk about where this market is geographically.
Yeah.
Where's most of the activity happening?
So in 2024, Asia-Pacific was the biggest player,
Okay.
about 40% of the total market.
Okay.
And that's because of the huge electronics manufacturing hubs in places like China, Japan, South Korea.
Right, right.
They're the global leaders in semiconductors and consumer electronics.
Right.
So it makes sense that they'd need the most alumina substrates.
Exactly.
And this trend is expected to continue. By 2025, Asia-Pacific is projected to have a 43% market share,
Wow.
driven by rapid industrialization, the boom in electric vehicles and battery technologies, and the rollout of 5G. The growth rate there is even higher, like 7.2%.
Wow. Okay. So it's safe to say that Asia Pacific is the place to watch for innovation and production in this space.
Absolutely, yeah. That's where a lot of the action is going to be.
Okay. So what about the other major regions?
Well, North America is the second largest,
Okay.
about 30% share in 2024.
Okay.
They're strong in semiconductor manufacturing. They invest a lot in research and development, especially advanced materials, and they're using more and more power electronics and renewable energy. So they're definitely a major player. Europe has a smaller share, around 20%, mainly driven by the industrial and automotive sectors.
Okay.
They really value reliability and performance in tough conditions.
Yeah, it sounds like a pretty competitive market.
It is very competitive.
Who are some of the big companies that are really leading the way?
Well, the top dog in 2024 was Murata Manufacturing,
Okay.
about 15% market share,
Okay.
followed by TDK Corporation at around 12%, and Tech with about 10%.
Okay.
These companies are constantly investing in R&D.
To make their products even better.
Yeah. They want better thermal conductivity, more durability, improved electrical performance. They've got to stay ahead of the curve. And we're also seeing a lot of mergers, acquisitions, and partnerships. Companies want to expand their product lines and get into new markets. It's a very dynamic landscape.
Okay. So we keep talking about alumina substrates and how important they are. Can you just break it down a little bit?
Sure.
Why are they the go-to for so many applications?
Basically, it comes down to three main things.
Mm-hmm.
They're incredibly stable at high temperatures, so they don't break down easily.
Okay.
They're really strong mechanically,
Right.
so they can withstand physical stress.
Okay.
And they're excellent electrical insulators,
Right, right.
which means they prevent unwanted current leakage.
Mm-hmm.
These are really important characteristics, especially for electronics.
Mm-hmm.
Reliability and performance are absolutely crucial in those applications.
Right. Are there other materials manufacturers might consider, like alternatives?
Yeah, there are a couple.
Okay.
Aluminum nitride, that's ALN, and beryllium oxide, BEO.
Okay.
So in 2024, alumina had about 50% of the market for ceramic substrates. ALN was at 30%, and BEO was at 15%.
Okay.
ALN is usually better at conducting heat than standard alumina.
Okay.
So it's good for really high power stuff where cost isn't the biggest concern.
Right.
BEO has great electrical properties.
Okay.
But alumina is still the most popular.
Right.
It's cost effective, and it works for a lot of different applications.
Right, right. Like a good all-rounder. Yeah.
And it's projected to grow even more to about 52% of the market by 2025.
Exactly, because it's being used more and more in power electronics, automotive electronics, RF, and microwave applications, which deal with the high-frequency signals in things like wireless communication and radar systems.
Okay, so alumina is really striking that balance
Yeah.
between performance and price.
Yeah, that sweet spot.
Okay, so let's shift gears a little bit and talk about the technological advances happening within the alumina substrates market itself.
Sure.
What kind of innovation are we seeing?
A lot of the innovation is being driven by advancements in power electronics and semiconductor manufacturing. The demand for high-performance substrates is just huge, especially in areas like 5G, electric vehicles, and advanced semiconductor packaging.
Okay.
Think about it. Cars are becoming more and more like computers on wheels with those advanced driver assistance systems.
Right.
All those systems generate a ton of data, which means a lot of heat.
Right. So you need really efficient heat dissipation in those processors. That's where high-performance alumina substrates come in.
Okay.
And it's not just the cars themselves. It's the whole electric vehicle ecosystem.
Right.
Charging stations, grid infrastructure, everything needs to be able to handle the increased power demands.
And are the big players in this market keeping up with these demands?
Yeah, they are. Companies like Murata Manufacturing and TDK Corporation are investing heavily in research and development. They want to make their substrates more reliable, and improve heat dissipation even further.
Mm-hmm.
A good example is Murata's announcement in January 2023.
Okay.
They came out with a next-generation alumina substrate with even better thermal conductivity.
Wow.
It's specifically designed for those high-power devices we've been talking about. This kind of innovation is essential if we want to keep pushing the boundaries of what's possible with electronics.
Okay, so we talked about Asia Pacific being a big market.
Right.
Are they also a hub for technological development in alumina substrates?
Yeah, definitely. While North America is strong in R&D and has those demands in sectors like power electronics and aerospace, Asia Pacific is the fastest growing in terms of both using and producing advanced substrates.
Okay.
Back in 2024, they had 30% of the global market, and they're projected to hit 33% by 2025. That's a 9% annual growth rate. That's huge.
That is huge.
It's all fueled by industrialization and massive investments in semiconductor manufacturing in China, Japan, and South Korea.
Okay, so looking ahead, what are some of the biggest opportunities for growth in this market?
Well, the report highlights a few key areas. First, there's the ongoing development of new and improved ceramic materials.
Okay.
Second, the range of applications for these materials is constantly expanding.
Mm-hmm.
And third, the adoption of alumina substrates in high-performance electronics just keeps growing. That's a major driver. One fundamental opportunity is just the sheer increasing need for these materials in electronics and semiconductors. The combination of thermal conductivity, mechanical strength, and electrical insulation is so valuable for making sure modern electronics are reliable and perform well. And the demand for reliable electronics is only going to increase, especially in industries like aerospace, automotive, and telecommunications.
Right. We talked about that impressive market growth in 2024. Can you give us some more specific examples of where that demand is coming from?
Yeah, sure. 2024 saw a big jump in demand from power electronics and high-frequency applications,
Okay.
especially with the rollout of 5G and the growth of the electric vehicle market, specifically the power modules that manage the flow of electricity in EVs.
Mm.
In fact, the electronic segment overall accounted for something like 45% of the total market revenue in 2024.
Wow. Okay, so what you're saying is if you're interested in the future of electronics, you really need to understand power electronics.
Absolutely. It's essential. Power electronics is how we control and convert electrical energy. It's at the heart of electric vehicles, renewable energy systems, industrial automation, so many things.
And it seems like these advancements in materials are also creating new growth opportunities in more niche areas, right?
Definitely. The use of high-purity alumina, or HPA, is making a big difference.
Okay.
Substrates made with HPA are more durable, they can handle higher temperatures, and they work better with the newest semiconductor technologies.
Mm-hmm.
We're also seeing more and more alumina substrates being used in high-performance LED lighting.
Okay.
Their heat dissipation properties are helping LEDs last longer and be more efficient.
Right. That's not something you'd immediately think of. High-tech ceramic substrates in your light bulbs.
Yeah, it's a good example of how these materials are often hidden in plain sight.
Mm-hmm.
And then there's the medical sector.
Okay.
Alumina is biocompatible
Mm-hmm.
and very reliable.
Right.
So it's perfect for medical devices.
Right.
Things like implantable devices and diagnostic equipment. And of course, the renewable energy sector is using alumina substrates in key components,
Right.
like photovoltaic inverters, which turn solar energy into electricity, and battery management systems.
Right.
This area is growing fast because of the global focus on sustainability. Think about the push for solar energy.
Right.
That's directly increasing demand for alumina substrates.
So all this sounds great, but are there any potential downsides or challenges for this market?
Well, there are a few things to keep in mind. Even though alumina is great at handling heat, it can be a bit brittle.
Okay.
So in applications where there's a lot of mechanical stress, there's a risk of fracture.
Right. Right. Makes sense.
And while alumina is generally good with heat, it doesn't always do well with sudden extreme temperature changes.
Okay.
It can be susceptible to something called thermal shock.
Okay.
This can cause tiny cracks in the material, which could eventually lead to problems,
Right.
especially in demanding environments like those found in power semiconductors or aerospace electronics. So we need to develop new materials or composites that can handle those situations even better.
Okay.
Another challenge is the cost. High-purity alumina substrates are expensive to make.
Okay.
The production process is complex, requires a lot of energy, and you need very precise formulations and strict quality control.
Right.
This can make it hard for some industries to adopt these materials, especially those that are really sensitive to costs.
Right.
The semiconductor industry, for example, is always looking for ways to save money.
Right.
And sometimes alternatives like silicon carbide, so G, or gallium nitride,
Yeah.
GNN, can be more cost-effective for certain applications, even though they might not be as versatile as alumina.
I see.
And then there's the issue of flexibility.
Oh, okay, right.
Traditional alumina substrates aren't very flexible.
Right, right.
And as electronics get smaller and more complex,
Hmm.
that can be a problem.
Right.
So manufacturers need to find ways to make their production more efficient,
Hmm.
reduce waste, and develop new materials that strike a better balance between cost and performance.
Right, right. So we've talked about the challenges, but what about the future?
Okay.
What advancements are we likely to see in the alumina substrates market?
The future is really exciting. We're
Well,
expecting to see some major technological advancements, especially because the demand for high-performance applications is just going through the roof. One of the big trends is going to be a shift away from those conventional substrates and towards more advanced composite materials.
okay.
And that leads us to something called Zirconia Toughened Alumina, or ZTA.
Okay, yeah, the report mentioned that. What's so special about ZTA?
Well, ZTA substrates are a pretty recent development,
All
and
right.
they're a game changer.
Okay.
They're much stronger and more stable than traditional alumina.
Mm-hmm. Mm-hmm.
A great example is Ceramtech. They're a big player in technical ceramics.
Okay.
Back in 2023, they introduced a new line of ZTA substrates specifically designed for power electronics and renewable energy.
Okay.
These ZTA substrates combine the high thermal conductivity of alumina with the incredible toughness of zirconia.
Right.
This makes them really well suited for tough industrial environments. They're less likely to crack and can handle rapid temperature changes much better. This is a huge improvement for things like power semiconductor modules, which are essential in electric vehicles, high voltage systems, all sorts of things.
So are there any other innovations in the pipeline? Anything else that we should be keeping an eye on?
Oh yeah, definitely. We're seeing more and more use of advanced manufacturing techniques like laser-assisted processing
Okay.
that lets manufacturers cut and shape these substrates with incredible precision.
Okay.
And then there's additive manufacturing, which is basically 3D printing.
Mm-hmm.
This allows them to create much more complex and smaller designs.
Okay.
It's all about making electronics smaller and more intricate.
Okay.
Another really interesting area is nano-engineered coatings.
Okay.
These are ultra-thin coatings that can be applied to the surface of alumina substrates to enhance their thermal and electrical properties.
Okay.
This could open up possibilities in cutting-edge fields like AI computing and quantum electronics. And over time, automation and precision manufacturing are going to drive down the cost of making these substrates while also improving their quality and performance.
Yeah.
It's really an exciting time to be following this field.
So to summarize, the alumina substrates market is booming.
Yeah,
Lots of potential for growth,
lots of potential.
but also some challenges that need to be addressed.
Absolutely.
The key opportunities are in advanced materials like ZTA, the growing range of applications for these substrates, and their critical role in supporting renewable energy technologies. But we can't forget about those challenges related to thermal and mechanical stability and the cost of manufacturing those high-performance substrates.
Right.
So what's the best way to approach these opportunities and overcome the challenges?
Well, research and development are going to be essential.
Right.
We need to create even more advanced materials that overcome the limitations of traditional alumina. And then we need to combine those material advances with new manufacturing techniques to make things smaller and more precise.
Right.
At the same time, we need to find ways to make these high-performing substrates more affordable
Right.
so that more industries can use them.
Right.
It's going to take collaboration between material suppliers, electronics manufacturers, and research institutions to really make progress.
So I guess the takeaway is we might not think about them every day, but these quote-unquote behind-the-scenes materials,
Right.
like alumina substrates, are really driving a lot of the tech that we depend on.
Yeah.
And if we want to see continued technological breakthroughs, we need to pay attention to these often overlooked but critical components.
Absolutely.
And who knows what other exciting discoveries and challenges are out there. That's something to think about.
Definitely food for thought.
Thanks for joining us on this deep dive. It's been a fascinating conversation.
Yeah, it has. Thanks for having me.
Anytime.